Welcome, ladies and gentlemen. So what I have is x cubed minus 3x plus 2 divided by x plus 2. And when doing long division, the main important thing we want to do first is make sure that we have them in descending order, and as well as that we can account for every single one of our terms. Because I think it becomes, sometimes students will get mixed up when we're missing a term. So for instance, you can see I have these in descending order, my divisors in descending order, which we always want to go from our highest degree down to our constant, so that works. Here, it's the same thing. 3 is the highest degree. And then I don't have a 2, but then it'd be 1 and then down to 0. So since I don't have a 2, I'm going to want to rewrite right in that term, though. I want to make sure that place is being held. So it'd be x cubed. Well, since I need a way to write x squared, but for actually it not actually being there. So how can I do that? Well, if I write 0x squared, 0 times x squared is always just going to be 0, which really is not going to change the answer. However, what it does is it gives us a placeholder of where x squared would be if we had a number otherwise 0. And this isn't necessary. You don't have to do it this way. But it's very important for synthetic division. So I kind of just get in the process of doing it for long division, even though you don't really have to do it. So now the next step is going through our process, our algorithm for long division. So the first thing we do is since it's in descending order, we always take our first term in our divisor and divide it into the first term of our dividend. So x divides into x cubed. And really what that's saying is x cubed divided by x. How many times does x divide into x cubed? Well, if we're using our properties of logarithm or properties of exponents, we would just say, oh, that's going to be equal to x squared. So therefore, I can just write an x squared over here. Then I need to make sure I multiply this term times each terms of my divisor. So I multiply by both of them. And x squared times x is going to give you x cubed. X squared times 2 is going to give you a 2x squared. And that's a positive 2x squared. OK, so now the next thing we need to do is we need to subtract the rows. And the way that I'm going to do it this way is I'm going to write my subtraction symbol, but it's very important that you literally say this out loud because it confuses a lot of students. X cubed minus x cubed. Well, that's really like 1x cubed minus 1x cubed is like 0x cubed, which is still going to go to 0. But then you have to do it again. It's 0x squared minus positive 2x squared. So it really looks like this. Well, 0 minus 2 is going to leave you with a negative 2x squared. So you can write the subtraction on there. Just make sure you say it out loud, because what I get so many times is students will subtract these, and then they'll add these. So they'll get a positive 2x. Big mistake. All right, so now we just do the division property again, or the algorithm again. Now I take x divided into negative 2x squared. So I just take negative 2x squared divided by x. And again, you can see this, hopefully, by using your properties of exponents. Which is just going to leave me with a negative 2x. Now again, I take that negative 2x and I multiply it by both terms. So negative 2x times x is going to give you negative 2x squared. And negative 2x times 2 is going to leave you with a negative 4x. Now, you can see that since we use this property, this 3x is way up here. So one thing I can do is I can kind of bring it down. And I'll bring down the 2 as well. Okay? And I like using different colors so it kind of sees, what am I doing? You can leave them up there and still subtract down, but a lot of times it's just helpful to have them closer to your numbers. So now, again, let's do our work here. Again, say it out loud. Negative 2x squared minus a negative. Well, remember, minus a negative is pretty much the same thing as like adding, which would make this a 0x squared. Then negative 3x squared minus a negative. Let's see what this looks like. Negative 3x minus a negative 4x. And I think it's very helpful. If you're having trouble with it, write it out. So you can see minus a negative, that turns positive, so that's just going to be x. And sometimes people like to teach, 2 minus 0. I don't really see a point in it, but you can just see 2 minus 0 is still going to bring you down your term 2. You could even bring down the 2 a little bit farther. Okay? So now let's apply the property, or let's apply it again. X divides into x one time. 1 times x is x. 1 times 2 is 2. positive 2. Obviously, ladies and gentlemen, when you subtract this minus that, you're going to get a remainder of 0. So therefore, x plus 2 evenly divides into the polynomial x cubed minus 3x plus 2. And it divides into that polynomial x squared minus 2x plus 1 times. Thanks.